So hexamethylene diamine is one of the monomers used, HMD. HMD stands for hexamethylene diamine. As we said, it is a condensation between diamines and dicarboxylic acid. So hexamethylene diamine. Let us write the structure. Hexa meaning 6. So CH2 6 times. Diamine meaning 2 NH2 groups are there. So NH2. Hexamethylene diamine. Plus adipic acid is a dicarboxylic acid. So you have CH2, it is a 6 carbon compound, 2 are used up for the COOH group. So middle there should be 4 CH2 groups. So CH2 4 times COOH and COOH. This is our adipic acid, which is a dicarboxylic acid. So nylon 6,6 is a polyamide. It is a condensation product of HMD, that is hexamethylene diamine, which is a 6 carbon diamine, and the other monomer is adipic acid, which is again a 6 carbon dicarboxylic acid. So condensation can happen, OH from here can be lost and one hydrogen can be lost from the NH2 group, and that can give rise to our polymer, that is NH. So this continues, CH2 6 times, NH, C double bond O, CH2 4 times, C double bond O, and that again continues N times. So that is a long chain polymer formed by the condensation reaction between hexamethylene diamine and adipic acid, both of which are 6 carbon compounds. That is the reason why this particular polymer or polyamide or nylon is called as nylon 6,6, and the temperature required here is 553 Kelvin. So quite high temperature is required over here, right, and that gives rise to nylon 6,6. Now let us see where this nylon 6,6 is used. Obviously we said it is produced in the form of fibrous solid. So you can produce fibers like our natural fibers. They can be woven into fabrics. So it is used in the textile industry. Nylon 6,6 is used in the textile industry for having these synthetic fibers. Not only textile industry, even nylon sheets are used for small kids for preventing bed wetting. Usually they use nylon sheets under the bed sheets, right? So nylon sheets are also made of nylon 6,6. So because of its properties, these are some of the applications of nylon 6,6, right? And even bristles of brushes. You use different types of brushes. You have toothbrushes, you have cleaning brushes. Any type of brush has bristles in it. So these bristles are usually, they should be tough and also flexible. So that is possible with the convenient properties of nylon 6,6. So the bristles of various types of brushes are also made of nylon 6,6. So this is one commercially important condensation polymer which is obtained by the condensation between hexamethylene diamine and adipic acid, both of which are 6 carbon compounds. That is why the name nylon 6,6, and due to its favorable physical properties, it is used in the areas of textile industry, in preparing sheets and in the bristles of brushes, right? And you require a higher temperature here. There is the temperature we have written over here, 553 Kelvin, right? So this is one example for the preparation of a condensation polymer. Now let us see how the second example of condensation polymer is prepared. We will continue with the polyamides. As we said, polyamides are condensation polymers of diamines and dicarboxylic acid. So let us take another example where you have a polyamide present. That example is nylon 6. So from the name itself you can make out that there is only one monomer involved over here, and that must be having 6 carbons in it. And what is the monomer in the preparation of, let us see, nylon 6. Nylon 6. Right? Now nylon 6 is a condensation polymer of caprolactam. Now caprolactam is a 7-membered ring having a structure like this. You have NH, C double bond O, and you have 5 CH2 groups arranged in a ring. So these are 4, that is the 5th one. So this compound, organic compound, is called caprolactam. Right? Now caprolactam on condensation in presence of water at quite a high temperature, not as high as in nylon 6, so it is 533 to 543 K. So around this temperature, this material undergoes condensation with itself. Identical molecules undergo condensation and give rise to this polymer. NH, the ring breaks up, say here, and you have NH, CH2 5 times and C double bond O, and this part gets repeated n times. So this is an example, this is the structure of nylon 6. So why is it called nylon 6? Because it is a self-condensation reaction of caprolactam, which is having 6 carbons. See, there are 5 CH2 groups and a CO group. So there are 6 carbons in the ring. The ring breaks up and it undergoes self-condensation, giving rise to the product, condensation polymer product, which is called as nylon 6. Now this is used in making tire cords. See, it is said that nylon wire is stronger than even a steel wire. So you can imagine, steel wire is very hard and it is high tensile strength, it can bear a lot of tension. But even more than the steel wire, the nylon wire has greater strength. That's why it is used for mountain climbing also. So it has to bear the weight of the mountain climber. So it should have enough tensile strength not to break when he is climbing the mountain. So that is why that is a favorable property of nylon 6. It has very high tensile strength. That is the reason why it is used for making tire cords, ropes. So these are some of the applications of this particular polymer, that is nylon 6. So nylon 6 is also a polyamide. It has this amide linkage, NHCO is there. That is why it is classified under the category of polyamides or nylons. Now let us see another type of condensation polymers where different functional groups are condensed. This is the condensation between the amino group and the carboxylic acid group. Now we will see condensation between the alcoholic group and the carboxylic acid group. That gives rise to esters. So the functional group formed by condensation between a hydroxyl group and a carboxyl group is an ester group. That's why those polymers are called as polyesters. Here we were talking about polyamides, where amino group and the carboxylic acid group underwent condensation. Let us go to the next category then of condensation polymers, that is polyesters. So polyamides and polyesters are condensation polymers. We have talked about polyamides. Now let us talk about polyesters. Polyesters. The second type, that is second type of condensation polymers. Polyesters. Well, usually they are available under the brand name of Dacron or Terilin. Right? They are actually Polyethylene terephthalate is the chemical name of this particular type of polyester. So, Dacron or terylene, let us take one example where the ester group is formed by condensation between the alcohol group and the carboxylic acid group. So, polyethylene terephthalate. So, ethylene glycol, the monomers that are used in the preparation of Dacron are ethylene glycol, CH2, CH2, this is the ethylene part, glycol having two OH groups on adjacent carbons. So, ethylene glycol, right, and terephthalic acid, it is a dicarboxylic acid. Terephthalic acid, it has a phenyl group attached, and on the other end you have COOH group. This particular monomer is called terephthalic acid. Right. Now, these two can undergo condensation. OH group from here and H group from here can be lost as water, minus water, and it can give rise to this polymer CH2, CH2, O, C double bond O, you have the benzene ring, C double bond O, N times. So, this is your Dacron. Dacron or terylene, this is crease resistant. What is the meaning of crease resistant? Why do we iron our clothes? Because we want to remove the creases. So, cotton and all the natural fibers, they are not crease resistant. You need to iron them, whereas polyester or terylene or Dacron are synthetic fabrics which do not need any ironing because they do not form creases. They are crease resistant. That is why the useful property of this particular polymer, that is Dacron or terylene, is that it is crease resistant. That is why it is used in making fabrics which are crease resistant. Like terylene is a very popular polyester fabric, right? And so, this is one example of the condensation polymerization between a diol and a dicarboxylic acid. So, an alcohol and an acid group on condensation give you an ester group. So, continuous condensation gives rise to a polymer which is called as a polyester, and the brand name for one of the polyesters is terylene or Dacron, and the chemical name is polyethylene terephthalate. Why? Because it is a polymer of ethylene glycol and terephthalic acid, right. So, this is one example for another type of condensation polymer, that is polyesters.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.